hope you can hear me. We are going to start with defining the system requirements for a satellite project. So in the middle here, I've put the satellite as the core part or as the central most piece here. And we are going to just list what subsystems we need to develop. So first of all, we have the onboard computer. Then we have the electrical power supply, command and data handling. We have the sensors of the subsystem, communication and ground station. Then you have the structure and thermal. So I'm going to start with this, just list out the requirements supposed to have or to do or to meet. So this should have what we call, so most of these systems are subject to change. So I'll just list what I think should be there. So we should have a 3v3 supply, should have a 5-volt supply. All right, should have because it's a satellite and they're using solar, charge some batteries. Should have a way of like charging or controlling the solar array, and then battery charging. Let's say diagnostics. We can also have boost converters here. Converters, I think we'll need them in case the battery is too low and there is no solar power energy that has been stored during, when the solar panels were deployed. We can have a boost converter at that point. Don't worry about the borders. We let it that as we move on. And then the other thing, because it's a satellite that we are assuming it will be launched on some carrier, some carrier on a space as a space payload. So the satellite must be able to know that it has been released from the carrier or from the vehicle. And this will have the release protection switch to activate the solar panels immediately the release is done. We also need something we call remove before light by RBF pins. All right. So charging, can have this and charge controller. Okay. All right. So the next thing is let's see about the simplest part is the structure. Not really simplest, but it doesn't have a lot of requirements. So we should have the frame and casing. You should also have the let's have the magnetokers here. Magnetokers. No. This is attitude determination and control. Frame and casing, and then thermal subsystem. So these will be linked to, we need to know the temperature of the satellite, so it should be linked to the sensors in a way. So here you can have something like a temperature sensor. Okay, So we have those two. Can delete this. If we find any other item that needs to be added, we'll add it to the list. Mhm. Mhm. So next thing you can do is communication and rest. Now you can do command data handling. So basically, it should be able to receive. What I'm thinking, it should be able to receive commands from the ground and also send commands or data from the satellite to the ground. So what type of data do we expect at this point? We can have like let's say command parser. This is mostly going to be software. So command parser. And then we also need to have some buffers and memories to act as an interface between command being received and the time it's being processed. So, okay, buffer, you can call it memory buffers, memory buffers. All right. Let's add what we know first. Communication. Now antenna, obviously. Uh, let's see. Antenna and transceiver modules. Can use LoRa most probably, or high frequency RF. Mm, let's see. Transceiver. All right, those are okay. Sensors. Obviously, we need to know the orientation of the satellite. So yeah, we need an MPU 6050. We need a sun or UV sensor. Can we make sure this thing is recording first? Okay. Um, what other sensor might we need? We might need a, okay, that's not really a sensor, but mag networkers. Let us put them here for the time being. We can move them later to maybe attitude determination and control. Mhm. So this sensor system needs to be very elaborate. So we need to know the position of the rocket, or the satellite in space. So we need a GPS sensors. We need we need others are very like miscellaneous stuff like ADCs. You can use modules. You can use pumps for that thing, for that purpose. We need to know the orientation of the satellite again. So we need to have, let me add it here. We need to have magnetometer, maybe a gyroscope to get the angular velocities. Gyroscope. Cool. Okay, gyroscope. Okay, gyroscope. So what's the work of the onboard computer? This will be software, so it will be linked to all of these subsystems. Okay, so the onboard computer will handle data reception. Okay, it will handle data storage. It will handle before storage. Okay, there's no order, but for now, you can say filtering, data cleanup, and filtering. All right. Then you can have subsystem checks, very easily and closely intertwined with what is called housekeeping. Just make sure that everything is functioning as it should, and then you should have command processing, and basically it controls all of these subsystems. So you can list a lot of functions, so we'll just keep them to that number for now. Let's I'm thinking we put on hold emission design, but emission can be something as simple as just capture, let's say, monochrome images. Should be defined better than that, but for now we can have that. All right. Okay, so you can have just connecting our arrows just to organize it a little bit. It's very essential that we lay out the requirements from the word go, so that by the time we start developing, we have a clear path of what we want to do, rather what we are doing. So I'll put that on just about there. This can be style. It's not really important for now, but we can just have it at the moment. Actually is the most important part, animation. But for now, for our case, we are interested in the technical side of things. We'll get to that. No worries about that. So let's put this somewhere around there. These two somewhere around there. But then we can rotate it. And this other guy. Rotate. Okay. Okay, so title here. This obviously is a project shadow of light. Subsystems. All right. These ones are mostly put in. Let's see. Oops. Okay, I hate doing this, but let me just do it. So, sorry. I'll copy this and then paste it here. here just to make this diagram look neater. Then arrange to back. Sure, should, yep, should be good. That is okay. And the other guys that are not okay at this one, so we can control V here, put it there, paste, paste, select all of them and send to back, save. Okay. I'm sure there's an easier way to do this, but I'll look for that, and maybe next time we are drawing such a diagram, we have a shortcut, because this is bad. This is bad. Back, okay. So you're going to develop all of these systems. All of these systems. You can have that. You can have just the same color, just for documentation purposes and to make it look neater and better. You know, it helps, goes a long, long, long way to have such kind of documentations. You can always refer back to them and change stuff and just get a clear view, because some of these things are going to get so deep, so we need a way to like backtrack to our to from the point we branched from. But all right, so I don't want to keep this video long, so I will let it be at that. Next time we'll develop the UML diagrams for a subsystem we want to tackle. Then we move on from there. All right. Have a good one.